The measures of dispersion follow the measures of central tendency. So the common measures of dispersion are standard deviation and variance. And if you are at a university or college, by now you know about the bell curve, which looks like this. And you know, often hear that this is one standard deviation of the mean, or within two standard deviation of the mean. So let's see what it means. What is standard deviation and how we compute it? Let's look at the age of an instructor. So let's say if the average age is 52, what does it mean? It means that the individual ages may differ. Some may be 48, some may be 55 or 75. So the average age is an estimate, but what we also need is an estimate for the dispersion in the data set. The other thing to note is the range, and in our data set, for example, the range is from a minimum of 29 years of age to a maximum of 73 years, and it's the distance or the difference between the minimum and the maximum. Now, unlike the mean, the main difference between a variance for the population and sample is that when you compute the population variance, you divide it by the total number of observations. These are the deviations between observation and the mean, the squared, and then add them, and then divide it by the total number of observations. And for sample, you divide it by n-1. We usually talk about standard deviation rather than the variance, and standard deviation is essentially the square root of the variance. And the variance is in square units, so it's good to use the standard deviation because it's exactly the same units as the variable. So the standard deviation of age will also be measured in years rather than square years, which would be variance. So here you see we just taken the square root of variance, and that becomes standard deviation. So we will return to our data set, and we will look at the variables. We've computed the mean and the maximum before, but now this time we'll add standard deviation to it. We will return to our data set now and use another command called Descriptive Statistics, and click on Descriptives, and we select the variables of choice, and then, for example, age of the instructor, and under options we have the mean, the standard deviation, minimum and maximum, and let's select the other variables as well. So we click on OK, and we have the same variables computed with the number of observations, minimum, maximum, mean, and standard deviation. Now let me explain why mean and standard deviation have to go hand in hand. And I will revert to this example from basketball and talk about the two giants of basketball, Michael Jordan, my favorite, and Wilt Chamberlain, who preceded Michael Jordan. Now, if you consider their average score per game, you would notice that they didn't differ much. Their average was around 30 points for both Jordan and Chamberlain. However, when you look at the standard deviation or variance in their performance, Michael Jordan was at around 4.76 compared to Chamberlain, who was at around 10.59. And here, if you were to plot this distribution to see how Michael Jordan and using the mean and standard deviation, assuming that their scores were normally distributed, you would notice that Michael Jordan's consistency comes out, and it's a very different distribution, very focused distribution compared to the one for Wilt Chamberlain. Same mean, 30, but you see that it's, the distribution is different, suggesting that Jordan was much more consistent in his performance than Wilt Chamberlain. We can also plot the variance using histogram in SPSS. So let's say we want to do this. We return to our data set, click on graphs. We have several choices. Let's say we use a legacy dialog box and say histogram, select the variable, which is the teaching evaluation score, and then say OK, and the output comes out here. You can see it's similar to the one that we've got in our slides. We can add titles and footnotes to our chart. And we can produce multiple histograms based on a variable, let's say gender. If we click here and then say OK, you see that we have got one drawn for females and one drawn for males. So the main argument in praise of standard deviation or variance is that average will, or the mean will paint a partial picture. If you really want to understand the complete picture for a variable, or for your data set, you have to compute both the average and the standard deviation to understand the variance. And notice that all risk metrics in finance have much to do with standard deviation. So a mean with a standard deviation means something more useful than the mean itself.